Okay, so 4.4 is populations and how we can estimate different population sizes in an ecosystem. And there's going to be really two different methods. And it really depends on if your organism or whatever you're sampling is able to move or not. The vocab that I assigned is from the textbook pages of 4.4. And that's where it'll discuss the differences between like what an ecosystem is versus a population, um, biotic factors that can affect a population. So, like predation, disease, competition, even some symbiosis relationships, and then some abiotic factors, and the term niche. So, what it means to hold a role in an ecosystem. But specifically, what we went over in class is just this first page that you see here. And this goes over the method called mark and recapture. And it is solved using the Lincoln index, which is this formula right here. And for any kind of, like scientific formulas that needed to be used on the exam, you will be given those, except, something like trying to find area. Those are like common knowledge things, and you'll need to know that, or even how to take a percent of something. But if it's any kind of scientific one, then you'll have to be able to reproduce that on your own. Okay, so this is the mark and recapture method, and we're going to use called the Lincoln index, and this is to estimate a population size for organisms that are able to move. And honestly, there's going to be a large area that needs to be covered, so it could be like a whole area of an ocean, or just a region of the ocean, or a really large intertidal region like this, where it would be pretty difficult to be able to individually count each different organism right there, including the ones that are underwater. So you're going to put marks on some of them, and then you're going to go back and reassess the population. But the methods are actually described in this page right here. So to practice this, and I'll also go through the different procedures. It says you have a group of 9 periwinkles, and I did actually take the original Cambridge picture out because it wouldn't have copied well, but this is what they look like. There's small mollusks that are found in the intertidal region, so the area between the high and low tide of many rocky shores. All right, so many rocky shores experience the most amount of erosion, but because they are made of rock, they are the most resistant to erosion. And all the wave action allows for very little sedimentation. Periwinkles feed on algae that grow on the surface of rocks. All right, and we know that algae are trophic level 1. And so the question now says state, it's one mark. So one word answer, the trophic level occupied by periwinkles. And so if they're feeding on algae, and algae are trophic level 1, your producers, then periwinkles are trophic level 2. And a common way that students would get this incorrect is because they do mention algae, sometimes they just don't read it well enough and they'll put trophic level 1, or they'll do what I told you not to do before and put herbivore or primary consumer. But that is not their trophic level. Levels need to be numbers. All right, the mark and release recapture technique, and it is exactly how it is. You're going to mark the organisms, release them, and then after some time, you're going to come back to recapture them and then assess the population. So it's for population densities, and again, they're for organisms that can move. Though this question isn't referring to like a marsh, but this is actually very remnant in this picture what I did when I was in a marine ecology class, and we took like a very vibrant nail polish, and the ones that we assessed, we did like put a mark on them, and then after some time, I think it was actually like our next time we met for labs, so we had Tuesday, Thursday labs, we went back and then we grabbed another population, and we assessed how many had a mark, and then we applied it to the formula. You can see it done right here, and they are also using nail polish. But there are some downsides to that, and we'll discuss that too. Okay, so the steps. This technique, a sample of animals is collected. Each one will be marked with a small dot of paint. For different organisms, There you go. So that's just the first step. So like for sea turtles, we'll cement satellite tags on them. For sharks, we do the same thing. We'll pierce their dorsal fin with a satellite tag. And because those are very large and vast migratory species, for bottlenose dolphins, typically they're done with with photography. Take a picture of their dorsal fin because dolphins have a dorsal fin that's very unique to them, almost like a fingerprint is to us. Okay, these animals then, you collect the sample, then you're gonna put some kind of mark on them. All right, the marked animals are then released back in their habitat. That's gonna be your second step. After a suitable time, and that's whatever you're waiting for, a second sample is then collected, and you're going to count how many are total in that second sample. And then you're going to separately assess within that second sample how many have the mark on it from the original sample. And then those are going to be counted. And then you're going to apply it to this formula. Now, this question I think is from 2016. I'll show you how it's changed. So they said N1 times N2, which is typical, divided by N3. So it's the amount in the first population that you captured and put the mark on it, multiplied by the total amount of organisms that were in the second sample, and you're going to divide it by the ones that have the mark that you first put on there within that second sample. And now they're calling it M3. Again, you don't have to memorize this, it'll be given to you. But if we scroll to the last page, this is from this new specimen paper, so for 2022. And so then they just said N for number. So the number of the population, how many are in there. N1 is going to be the amount, again, still in the first sample size. N2 is the total amount you caught in the second sample, and then you're going to divide it by M2, which M2 is going to stand for the amount of organisms within that second sample that have the original mark from the first one. Again, you are given those formulas. You don't have to memorize formulas, you just need to know how to answer them. Okay. And so we will need to be familiar with these steps. So you grab a sample size from an area and you put some sort of mark on there, and then you will release them back to their habitat. And ideally, you should distribute them in an even distribution, kind of like you just found them. And then you'll go back after like a desired time frame. You should go back at the same time of the day, maybe during the same type of weather conditions. And so that at least can try and be as controlled as possible. And then you'll count your entire the sampled population you got on the second trip, and then identify the ones that have the original mark. Okay, and so here's your practice question. Oh gosh, a yellow pen. No, thank you. Okay, so in an investigation, 204 periwinkles, they were collected and then marked, and then they were returned to their habitat. All right, 2 days later, they took another random sample of 936, and of that 936, 72 had that original mark. And so we're going to apply it to our formula. Okay, so the amount in the first sample was 204 times the amount in the second sample, which is 936, divided by the ones that had the mark, 72. All right, and then you should find that your total amount in that sample, 2,652, and consider the units that you're using. So just what are they trying to find? They're looking for the number of periwinkles. So this is the number, 2,652 periwinkles. Remember, the units are always going to be given in the question. You just got to be able to find it and show your work. Even though you're like, oh, this is like multiplication and then division, definitely show your work, because if you do end up writing down the wrong number on accident, or perhaps you type it in your calculator wrong, you can at least get 1 mark back for having the correct answer. That's 2 marks. Okay, and now we're going to have to put into some basic, just some basic, I don't know if you call it area geometry, algebra, just basic math. So in the investigation of a rocky shore, in this investigation, your total that you assumed in that population was 2,652. And they tell you that the area that they were trying to sample is 20 meters by 20 meters. All right, so use your answer from the previous question. And you want to find the average number of periwinkles per square meter. So they want you to answer how many then are in just one per square meter, just 1 square meter. You know that you have 2,652 in a 20 by 20 square meter area. So then we're going to need to divide that and figure out if that's how many's in the total, then how many would just be in one. Okay, and they want to have the answer. That's the answer, the unit that they want. Periwinkles per square meter. So I know that needs to be my unit. Per meter squared. All right, to get the meter squared, you're going to have to do meter times the meter. And so you'll do 20 times 20. Okay, you get 400. Meter times meter is meter squared. So you're going to now, that needs to be in your denominator, and you're dividing by the total amount. So 2,652. Okay, and when you divide those out, you'll get about 6.63, or we could do 6.6 periwinkles per square meter. Okay, and I'm going to scroll down to the bottom one. And we did that one in class. And we're going to use this to calculate we'll just do this first part, letter A for this. So here's a shoal of bluefin snapper. All right, and they give you the scientific name. Notice the genus is capitalized and the species is lowercase. In the 1950s, these fish were introduced to some Hawaiian islands where their numbers have gradually decreased. Okay, scientists use the mark and recapture method. That's very large. To estimate the population size of those snapper living on the reef. The scientists use nets to catch the fish. So not a hook, because you don't want to damage them. Minimum damage as possible. To mark the fish with a harmless tag. So I like that they mentioned harmless. You don't want to have a negative effect on your organisms. It was attached to their fins, the fins of the fish. The fish were then released. 2 weeks later, they caught their second sample. And so here are your results. So the number of fish caught and marked in the first sample was 52. So that is going to be your N1. The total number of fish caught in the second sample was 41. That's your total. That's going to be your N2. And it says marked and unmarked in the second, the total number. And then your N3, the number of marked fish. So within this sample, how many of them had that original mark from the first time they caught them? 12. That's your M2. Okay, and so this is, again, the Lincoln Index. You don't have to memorize it, but you do have to be familiar with it, and you do have to know how to use it. Of course, you'll all be using calculators on your Cambridge exam. All right, so calculate the total population size. 52 times 41 all over 12. I'm getting my calculator out. That's going to be 2,132 all over 12. Okay, and they want you answering to 3 significant figures. So you're going to end up getting 177.66 repeating. If you rounded it to 177.7, you have 4 significant figures there. So to get the 3, it's just going to be the 177, but rounded up. Oh, I don't like the way that looks. The 177, but rounded up. You only want 3 significant figures. So your answer is going to be 178. because that will round it up. Okay. You can get 1 mark if, one, you do the right math and you put the wrong significant figures in there. So if you put 177.7, you will still get 1 mark. If you put 177.6 repeating, or actually not even 6 repeating, but because it is 6 repeating, you should do 0.67. That will still only get you 1 mark. So you need to get that correct, you do need to only answer to the 3 significant figures. Okay, let's go back to the top. Suggest 3 reasons why the mark and release recapture technique may not be an accurate measure of the actual population of those periwinkles. It does not matter, honestly, for any organism. These answers will apply to any mark and recapture example. Because I always want to know, what are the limits to this? Like, it's correct, but like, why isn't it like the best? Like, where could there be some things missing? All right. So one of the things is, if we just like look back and consider, these with the bright pink dot are going to be very obvious to you. You can see these ones right here. Those are very obvious to you. And due to that, when you go back for the second sample, there you go. When you go back for the second sample, and they even say the marked animals are then released, a second sample is collected. Oh, sorry, I'm reading the wrong part. There we go. On this one, a random sample. When they go back, they take another random sample. It's going to be hard to make it truly random if your eyes are drawn to this bright pink dot on a darker organism. You know, they're much easier to see than like these ones right here that didn't have the mark on it. So that's going to be one of your reasons, is the mark may encourage recapture. And if that happens, and that's because we're human, if we're more prone to just capturing an organism just because we see that mark on them, well, then that's going to cause this number, that's going to cause this number right here to end up being much higher than it actually is. Because our eyes are going to be more drawn to something that's more vibrant. So on this M2, right? M3, the amount of organisms in the second sample that had that mark, we're going to be more drawn to it. Then naturally we will be picking out those ones more often because we see them. And so it'll cause it to seem like we actually have more in that random sample, which now isn't random, than we actually do. And that will cause this number to be higher than it is. And if we are dividing by an even higher number, our result is going to be smaller, just math. So our result will look like the population is smaller than it is. But that's going to be one of the limits. So we could say the mark may encourage recapture. And now it's not random anymore. Additionally, if you consider like their dark color, especially on these, they're living in a dark substrate, like a muddy substrate. These ones are in a marsh. It makes sense that their shells are darker. That's going to help them with camouflage, or even if we did it with like little scallops, it will mess up their camouflage. These ones too, right? They kind of blend in with, they're going to blend in with the substrate below them. So that will make them more susceptible to predation. So the mark could increase predation. All right. When using nail polish, right? We're not saying it's gel, it's nothing like that. But so nail polish or any sort of paint that you put on there, especially being outside in the elements against waves and currents, the mark could wear off, and then if the mark wears off, well, then within that second sample we collect them, we're not going to realize that one of these periwinkles or one of these organisms were something we already accounted for, then this number, and the 72, the amount marked in the second sample, the M3, that could actually seem like it's lower than it actually is because the mark wore off. And now if we're dividing by a lower number, it will increase the population size. And so that could fluctuate that could cause the numbers to fluctuate. Okay. Things that they're not assuming, but again, this is a method that it's not 100% accurate, but it is easier than having a human go out there and try to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Like, we're going to make a mistake counting that way. But one thing that it doesn't assume is the amount of organisms that have either been born or have died. And honestly, in a mollusk, a new organism is going to be in its larval phase, and it is definitely not going to be on the substrate yet. It's going to be planktonic and floating at the surface. But this doesn't account for births and deaths. Likewise, where the quotes mean whatever is above it, just bring it down. This doesn't account for any immigration or emigration or some periwinkles that have moved in or moved out of the area. All right, we're going to have 2 more marks. And again, these answers can apply to any mark and recapture example where it talks about like what are the limits there. All right. The mark could harm them, right? So there's a reason why we don't use spray paint, or we're not piercing their shell where we can pierce a dorsal fin because cartilage, we're not piercing their shell. Obviously, it'll make them way more susceptible to predation and disease. They'll be way more vulnerable, but the mark could harm them. And the last one actually is, this one would be actually feeding itself more to a group of smaller organisms like these that you could actually just pick up and put in your sample. Oh, sorry. And then put the mark on them and then bring them back. So if you did collect, let's say half of these, right? And then you took them all with you. Let's say you took all these. You grab them really quick. You put the marks on them. Awesome, awesome, awesome. And then you brought them back to this habitat. Just because we're humans, most likely we're not going to spread them out the way that they originally were. We might just have them like in our bucket, whatever we're using, and dump them in the same place. And so if that's the case, then when we go back for our second sample, packed all in one big area, we're going to find just a massive amount with this original mark on them. And again, that's going to make it seem like we have way more marked than we needed, or that we actually did, because they really didn't get to move that far. They are slow moving, but we did not put them back in their original distribution. They were put back in like a clump distribution. And if we get more than is accurate with that original mark, again, then this number, the M3, is going to seem higher than it is, which will mean we're dividing by a bigger number than we actually need to, and this population is going to seem lower. Okay, so that's when we're returning them back to their habitat. Sometimes we just dump them back and we don't actually spread them out as they were found originally. So when replaced, or you could say return to their habitat, they may be not, or you could say may not be, evenly distributed. All right, and it's important that we know the limits, because if we look at this entire thing, the limits are where your marks were the highest. right, so that's the limits to mark and recapture. Going down to that other example, this one asks a certain thing. And the limits, actually, their questions right there, and we will answer that one too. But going down to this second question, it says discuss, so talk out the factors that should be considered when collecting the samples so that an accurate estimate, so you don't really want any bias or any extra human error put in, an accurate estimate of the population size is obtained. So things you want to consider. One is like the amount of effort you're putting in, or really like the work you're putting in needs to be consistent. So if you are, staying out, for 3 hours one day, you're going to want to actually maintain that same thing, same amount of time on the second time that you go out there to capture them. It says that they were caught and they used nets to catch them. So maybe I don't know, like maybe you went to the gym in between those two sample days and your arm's a little bit sore on the second day. But that really can't be a factor in, like, I really didn't want to try and lift up heavy fish or try and constantly be scooping through the water. The effort needs to be the same. And that includes maybe like the amount of people that were involved trying to catch them. One day, maybe you have 5 people sampling, and the next day only 2 could make it. That is not going to be a great estimate for your population size. So maintain the same type of effort. So you want like amount of people sampling, the time you're spending in the habitat, the net size. Okay, location also needs to be considered. Sample at the same location on the reef. Naturally, there may be places that they're going to avoid more than others. Maybe they don't want to avoid an area that's more susceptible to tidal changes or feels a stronger current, or it could be an area in the reef where you might have a lot more people like diving, an area where like an ecotourism boat might take people out to dive and observe it. Fish could naturally avoid that. Along with same location, we'll want to sample at the same time of the day. Okay. If you're sampling again with like the time of the day, things that do fluctuate daily, just a little bit, are going to be your tidal cycles. Like high tide and low tide are going to be at just maybe minutes off each other, because that's also like how our moon phases may change. So you want to say like that would be something you want to consider, is taking samples at the same point in the tidal cycle. Like both days I sampled at low tide, then you're going to want to maintain that. Same point in a tidal cycle. What you don't want to say: you can say high or low tide. So like make sure you're sampling. If you're sampling at high tide, make sure you sample at high tide the second day. Don't say spring or neap. Those are not fluctuating throughout the day. Those happen within an entire month. where your spring tide has the largest tidal range and it happens on new moons or full moons. And that's when the earth, moon, and sun are at 180 degrees of each other or they are parallel to each other. The neap tide is at a crescent moon or a quarter moon, and that happens when the tidal range, the difference between your highs and your lows, is the lowest. So your high tide isn't that high, your low tide isn't that low, and the earth, moon, and sun are perpendicular from each other. They're at 90-degree angles. So those are like those aren't going to fluctuate on the daily. Or those are things that would happen like within that month. All right. This one's kind of vague, but it does recommend saying having an appropriate length of time between samples, between the two. So you wouldn't want to let like a hurricane pass by and then go take a second sample. You wouldn't want there to be, oh, excuse me, like a large seasonal change happening and then taking your second sample. Or maybe it's like spring break week and you're like, okay, well, I'm going to avoid the reef for a little bit. Not even spring break week. What is it, like for like 3 weeks? Um, you do your first sample in the very beginning of March and then you take your second sample in like mid-April. You definitely don't want to have that happen because then there's going to be a lot of human interaction, a lot of human interference in between like those different sample times. So that would be like an appropriate length of time between samples. Another one they recommend then some factors to consider to make sure it's very accurate is attaching the tags the same way because some people sampling may attach it a certain way on one fin that somebody else put it on another fin. You wouldn't want to put it on a fin where it could directly affect like their main method of like moving, so or of like swimming speed, which would be their caudal fin. You wouldn't want it to weigh down their pectoral fins. So, and you wouldn't want it to be something that maybe a predator could grab and pull off, or you want them to be attached in the same location in the same way. So, ensure tags are placed in the same manner or they're placed in the same way. Okay, and then considering back this formula for the next question. Describe, so describe again, basic command word is what? And to get that second mark, and they just said one, you got one shot at this, 2 marks. So for the 2 marks, you need to describe and you need to explain. So describe and explain. So that's what and then why or how. One limit to using the Lincoln Index to estimate population size. And if we go back to what we wrote up here, okay, it could encourage recapture. Again, that means our eyes are looking more at the ones that are marked the second time, so that would make this number increase. You divide by a bigger number, then this is end up going to be smaller. Our actual population size is going to be much smaller. That right there is one of the limits. If a tag falls off, well, then this number that we're dividing by, the number that you're dividing by, if a tag falls off, that number is actually going to be lower than what it actually should be because now a tagged individual doesn't have that tag anymore. So now we're dividing by a smaller number, which will make your overall population look much bigger. If that tag encourages predation, maybe slows down their swimming ability or slows down their hydrodynamic efficiency, then they will be more susceptible to predation. That means they're not going to be counted within that marked sample, that second marked sample. Again, that number is going to look lower. The denominator will be lower than it actually is, and then you will be dividing by a smaller number. The population may look bigger. If fish die in between, then again, you're going to be dividing by a smaller number right there. So we'll list some reasons there. If the tag comes off, so you're going to get 1 mark for the describe and then another mark for the explanation, and you only got 1 shot at this. So pick one that you're certain of. Okay, and the explanation. All right, and then, yeah, overall, that'll make your population look like it is bigger than it actually is. The fish can enter, or, oops, in the same one, you could say the fish could leave. So the fish could enter, or the fish could leave the ecosystem. Between samples. All right, and that could cause the M2 to be smaller than it is. If they leave, or if they are coming in, it could make the second sample, right? Just the total, your N2, the total in that second sample. You have more coming in the second time you go out, it could make that seem larger. But that depends on if you're saying entering or leaving. You wouldn't say both of these like that. You would need to choose one or the other. So it could cause the M2, or even the N2, or N2. If you have a lot of them entering in between your samples, well, then your N2 is actually going to be larger than it is. Likewise, if you have a lot of them leaving, then your N2 will be smaller than it should be. And it will also cause the marked sample to look like it's smaller because they left. There's more. And I do recommend writing all these down, as I always say, because I would never count on yourself to, or even myself, like human error, to just remember one thing. It's better to have a lot of other options too. Okay, the fish could die in between samples. And this could cause the marked sample in the second one. So this, when you go back and you assess it and you look at all the ones that are marked, that could cause your M2 or even the N2, the total amount in that second one. So the number of fish caught in your second sample, if there was a lot dying in between, then this number could be lower than it really is. And additionally, if they were dying, I imagine some with the original mark would be dying too, so those numbers could be smaller. Okay. Little details. If you go there and you get a very small sample size, so maybe you don't get 52, maybe you grab 12, that's going to be like a really poor estimate of the overall population. And that's something like some background knowledge you would probably want to have beforehand. If the sample size is too small, then when you go back, just your opportunity in that second sample, if your sample size is so small to begin with, then when you go back, you're only going to actually have a small sample size that had that original mark, and that's going to make it look like the population is way bigger than it is. So you need to make sure you get an accurate population size. So first, sample size is small. And this could cause the N2 to be too small. This increases the calculation errors. Okay. So those are it for the mark and recapture. I'm gonna continue this in a little bit, and but this will be it for the mark and recapture examples. And I will continue on this and do the rest for the random sampling.